Well, here we are on day number 5 of 7. On our last lesson, we looked at the first part of 4.3. We had 3 simple machines that were introduced. Today we introduced the final 3. We had the inclined plane, we had the wedge, we had a screw. Now we get into the final 3. First one is a lever. Lever, what it's going to do, it's going to pivot around a fixed point. That point's called the fulcrum. So anytime you use something that uses rotational motion, something that pivots around a fixed joint, that would be using a lever. If you think about the middle part of the scissors, there's a screw in the middle part of the scissors in which the blades pivot from. That would be your fulcrum. Other fulcrums, you could have them on teeter-totters, on a teeter-totter or a seesaw. The very middle part, the whole bar pivots on that single point right there. This is how levers work. A few examples. Wheelbarrow pivots around the wheel. Door pivots on the hinges. Scissors, talked about that. Pliers, you pivot them around whatever the object is you're trying to put on or remove. There's 3 types of levers: first class, second class, third class. First class will multiply force and change direction. Scissors, the direction changes. It also multiplies force. Pliers, same thing. Seesaw, same thing. Second class only multiplies force. It doesn't change the direction, and it doesn't multiply the distance. Doors, direction doesn't change. Nutcracker, direction doesn't change. Bottle opener, direction doesn't change. You push up on the bottle opener, and the bottle, well, the cap comes up, so it goes in the same direction. Type 3 multiplies the distance. Fishing rods, shovels, and baseball bats. Fishing rod, it all rotates from the reel. Shovel, it pivots around whichever part you're holding on to. And if you're sticking it in the ground, it'll pivot from the ground. Baseball bat pivots from the knob of the bat. IMA for a lever. It's a really, really, really big equation, and slides wasn't all about me putting it in here, so check your book for this one. But it's a lot of words. Machine type 5, wheel and axle. It's got circular objects fastened, and they rotate on a common axis. The difference between a wheel and an axle is just the size, really. One of them is wider than the other one is, the wheel. Think about your car. The wheel on a car has many inches. The axle that holds that wheel together, nowhere near as many inches. It's much smaller in diameter. IMA for a wheel and axle. Guess what? Slides wasn't all about this one either. So check your book for the IMA for the wheel and axle. How does a screwdriver act as a wheel and axle? Think about this. Where you spin the screwdriver from, it has a thick point. But then inside that, it's usually like a clear plastic, you can see this smaller axle on the inside. So you spin this outside part, which is the wheel, which then spins the axle on the inside part. Same thing happens in your car. The wheel spins, and that is what turns the axle. The wheel moves first. You turn the handle, and the metal piece that's on the inside, aka the axle, rotates as well. Type number 6, pulleys. These are very, very useful. What do they change? They change 2 things. They change how much force gets put into it. So they may not always increase how much force you apply, but they're always going to change the direction. It depends on the type of pulley that you use. A fixed pulley, this is just one that has one gear. So you pull down on it, the rope goes through the gear, and it pulls an object upwards. The maximum mechanical advantage you can get is 1. So it multiplies your force by 1 throughout the machine. Movable pulley. So this is one that'll move up and down along the rope, chain, whatever it's attached to. It will at least double how much force you put in. Then a pulley system. Pulley system, it depends on how many gears you put in the system. The more gears you put, the bigger your mechanical advantage can be in the end. If you put 3 gears in here, then it has the opportunity to increase your force by 3. If you put 5 gears, potential to increase your mechanical advantage by 5. And then with 5-3 compound machines. A compound machine is something that uses 2 or more simple machines to do a task. Most things that we use are compound machines. They have more than just one machine in them. Cars, the gift changer in your car is a lever. The wheel that's in your car, like the steering wheel, it's a wheel and axle. The wheels on your car, wheel and axle. If you have crank down or crank up windows, those are levers. If you have switches in order to lock the car or to put the windows down, also levers. So there's just a few there. Bicycles will do the same thing. They have a lot. Pencil sharpeners have a few in there. They use wedges on the inside to sharpen the pencil. They have levers on the outside to crank around, unless you have an electronic one. But this is just a few examples of a couple compound machines here. They sometimes use gears to groove the wheel wrapped around a rope, a chain, or a cable. What kind of simple machine uses a gear? Wheel and axle. Wheel and axles have plenty of gears in them. If you have a lot of gears, you generally get a lot of friction with that. That's why it's important to keep gears lubricated so there's less friction that is applied to it. Last section we're going to get into is 4.4. That'll happen on our next day, and that'll actually be our last lesson of remote learning. Today is the end of day 5. Because we introduced 3 more simple machines, we get to do day 5 video project as well. And then when we get into day 6, it's all about machines that are found in the human body. We'll see you soon on the Google Meets.